Hello everyone. Today I'm going to explain you about how to write Arduino programs for studying the performance of the moving average filter and first order derivative filter. First one, moving average filter, where the formula is y of n equals to 1 by L sigma k to L equals to x of n minus k. Here, first of all, I have taken 1000 samples of PPT data. X is the 1000 samples of the data which I have taken, and y will be generally output where y of j is my output, j and I have given serial baud rate 9600, and now this is main algorithm I have taken. Where for int k equals to 0, k less than equals to 4, k plus plus, and this is the main one, sum equals to sum plus x of j plus k, in which I will get the moving average filter. First of all, moving average filter is a simple low pass amplifier filter commonly used for regulating an array of samples. This array of samples or signal, it takes all the m samples of input. It takes all the m samples of input at a time and takes average of those to produce a single output point. So now let's see the output. Verify it. Compiling is done and then upload to Arduino. Uploading is also done. Now let's check the plot. This is the signal, and let's compare this input as well. So this is the required signal we get for the moving average filter, and the second one is derivative filter first order difference, with the formula is y of n equals to x of n minus x of n minus 1, and the derivative filter, like in any digital system, there will always be a noise due to inherent quantization of numerical representation format, and therefore it will always be amplified of using the given first difference filter, where first difference filter let y of n equals to x of n plus p of n will signal which we want to filter with x of n, the useful part of the signal, and we often some additive white Gaussian noise of variance sigma square and the bandwidth of interest. Any filtering with your first order difference filter, which of n equals to delta n minus delta of n minus delta n minus 1, we get x of n minus x of n minus x of n minus 1 plus v of n minus v of n minus 1, where x of n minus x of n minus is the useful part, and we obtain after filtering as thus doubled and is given by 2 sigma square. And the same here I have taken top examples of my data and given baud rate 9600, and so here I have given L equals to 8. This is done L equals to 8, where it is length of moving average filter. Using moving average filter with first order difference of derivative filter is done. This part is the moving average filter part, which we have done with the first one, and here this will explain the derivative filter of first order difference. And let's see the plot here. This is the required output we get for the first order difference of derivative filter using moving average filter. And the third one is derivative filter, 3-point central differences y of n equals to x of n minus x of n minus 2. For the experiment, we have used the signal sampled at 100 Hz, and it seems to be kind of weighted central difference formula over different time intervals, maybe to minimize the effect of noise on the signal for shorter time intervals. And the same here, I have taken 1000 samples where float y equals 1000, float a, b, int n equals to 1000, and l, which is length, and we have well serial baud rate, and here it is a main algorithm. This part is the main algorithm. A commonly used variation of this algorithm computes the average slope between the adjacent point, which is called central difference method. Its advantage is that it does not involve a shift in the x-axis position of the derivative. This where we get y of j is our output, and this is for the plotting of the signal, and this is the main algorithm for 3-point central difference of derivative filter using moving average filter. And now let's see the plot. This is the plot for the central difference, 3-point central difference of derivative filter. And for the third one, and for the last one is how, this is the fourth one, which is how to find out the output of signal processing system which performs derivative filter and then performs match moving average filter with n equals to 8. So here same